Okay, welcome back. We're going to look at the battery charging circuit. And before we do, I have to get my airliner up and running here, so I'll just be a second. Please stand by. Okay, so here is our battery charging circuit, and we're going to evaluate how this whole thing works. And the very first thing we're going to do is we're going to take a look at the battery portion as compared to really your output up here. This output section here is where we get our voltage output, and of course if you take a look, that's a center tap full wave rectifier. So just remember that the charging circuit itself is really only across half of that secondary. So we're just going to erase this here. Okay. All right, so we're going to start by looking at what happens when the rectified output is less than the battery voltage. And in order to do that, we have to take a look at really what happens when when our source excuse me, when our source is less than the battery. So if we were to draw a line here, that's supposed to be a line, not working out so good. The idea being, I think my computer's a little slow here. So anything above this point here is actually when the source exceeds the battery voltage itself. So we're actually looking on the bottom side here of what happens when the battery voltage is actually more than the source. And as you can see, I've shown the majority of the circuit here for you to take a look at. And then over on the left over here, you'll also notice that we have some switches. We have this switch here, which will indicate whether my thyristor, and I'm going to be using these two switches here to talk about SCR1. Just remember, it's a 4-layered device, and in order for it to conduct, both switches have to be closed. The top switch has everything to do with forward biased. The bottom switch, of course, which is down here, this is what happens when we get a proper gated SCR with a proper pulse. So the very first thing we have to look at is, you know, right now when the battery actually has exceeded, or the rectified voltage has has not started to charge the battery yet, then we have to see what happens with some positive and negatives on this particular diagram. So what we're going to do is we're going to go down here and we're going to take a look at this point right here. So when the battery has a larger voltage than the supply, and essentially that's really what's happening at this point, is that the supply hasn't risen above the battery voltage. So again, we're in this region down here somewhere where the battery actually has a larger voltage than the supply. And assuming that the battery has a bigger voltage than the supply, then what we need to do is we need to look at what happens right here at this anode, or sorry, cathode. There's the cathode of our SCR. So the question is that cathode more positive with respect to the anode? And the answer is yes. What happens is the electrical pressure, and it's really a tug of war between which one has the higher voltage, the battery or the supply. So if the battery has a higher voltage, it has a tendency to want to push positive ions towards the cathode. And when it does that, that causes the cathode to become positive, which also causes the gate to become positive. And of course, when that happens, that automatically means that my anode becomes negative. So when my anode is negative, I have a reverse bias situation, and that's why over here you can see that this switch right here is open, because we have a reverse bias situation. Now, more often than not, that also means that the gate itself is also negative. However, because in this particular circumstance there's no current flowing over here on SCR2, there's only one place for electrical pressure, and what we are seeing right now is that you're a positive here on the diode, on the anode, and a negative here. That makes this positive here, because again, the battery is causing both the cathode and the gate to be positive. That really means that if our gate is positive, we have enough of a pulse there to trigger or to cause that second switch, which is the trigger, to close. However, the SCR does not conduct even though this switch here is in a closed position, because it is not forward biased. So that's really, when we look at rather the rectified output being less than the battery voltage is pushing against the cathode of that SCR, which is causing it to be reverse biased, even though it's being gated because we have a positive at the gate. So just keep that in mind as we work our way through this. So at this point, we're going to move to the next slide, and you'll just have to bear with me, and we'll see if we can't work our mouse over here and get to the next slide. There we go. And we're going to take a look at what happens when the rectified voltage becomes greater than the battery voltage. So really all we're doing, you guys, is we're looking at what's happening with SCR1. SCR2 is not conducting at this point, so we know that there's only one place for possible current to flow, and that's going to be through SCR1. And SCR1 is what feeds the battery. That's what causes current to flow to the battery and charge. So again, we're going to now take a look at, and I'll use a different color here, we're going to look at what happens when the battery or the rectified voltage goes above the battery. So what we're getting at is this part right here is the battery voltage, and anything above it, my rating on this thing isn't great, but hopefully you can get the idea here. So anything above that, so this area up top, when our supply rises above the battery voltage, now all of a sudden we have that same tug of war changes as far as SCR1 is concerned. So now down here, the tug of war, there is more electrical pressure on the anode of this SCR than there is on the cathode, because the source voltage has a higher electrical potential than the battery does down here. That has a tendency to cause positive ions to want to be pushed to the cathode, and so we now have a forward biased condition. Now we already know that switch 2 over here, this thing was already closed because we had a positive at the gate even when the battery had a higher voltage. So that switch was already closed. So all we had to do was close this switch up here in order for this SCR2 to conduct. And we did that as soon as the electrical pressure on the anode became more than the electrical pressure of the battery. We now have a forward bias condition, and current now will not only go this way through the load and through the diode to the gate, but it will also come, we now are in conduction, and current will flow to the battery and charge the battery. So stand by as we move on to our next slide here. So we're going to now take a look at what happens when the battery reaches full charge. as we've already pointed out, the the battery will only charge when the supply has a higher electrical potential than the battery itself. So as the battery voltage begins to actually increase and get higher, this line right here actually gets higher and higher. So really what's happening is, I'm just going to erase this here. So we're going to take that out and we're going to put in, we're going to show you a higher battery voltage. So in other words, the battery is somewhere there. Now there isn't a lot of time at this point for the actual, so the battery has basically reached full charge or very close to it. There isn't a lot of time for conduction here. In other words, when the supply is higher than the battery, it's not higher for very long before all of a sudden the battery is going to turn that SCR1 off. And remember, the battery will turn SCR1 off down here when its electrical pressure right in this area here becomes more than the electrical pressure of the supply. It tries pushing positive ions into the cathode gate region. And what that does, again, I'll just erase this, that is automatically going to change the biasing of SCR1. So when that battery potential is greater than the supply, then what happens is that now the SCR has a positive potential at the cathode and also a positive potential at the gate. Now, as soon as that becomes positive, that also means that this diode over here, that becomes positive and that becomes negative. We now have a reverse bias diode when this happens. When this source voltage comes down over here, right there, what happens is that battery potential down here causes again positive ions to be pushed into the cathode gate region, which ends up reverse biasing the diode. So that turns off our trigger, which actually will open up gate switch 2, and because it's now reverse bias, because don't forget we have a reverse bias SCR, it will also open up this switch here. So when the battery reaches full charge, well, when the battery reaches full charge, clearly the battery voltage is not receiving a lot of current from the supply because the supply is actually at a higher potential than the battery for very little time. So then we have to start looking at the bottom half of this whole deal here, and we have to find out what happens with this zener and SCR2 as the battery voltage. So as this voltage here, come on, sorry, stand by, just having problems. Okay, so as this voltage increases, it's going to drop electrical potential across these particular resistors. So resistor 4 and 5 split the battery voltage according to the current flow through those 2 points. Now, as electricians, we actually can alter what voltage is dropped across R5 by moving this pot wiper, and that's what that little arrow is. And it's just a potentiometer. You've probably used them before, and the idea there is that we can alter the voltage that will be dropped across R5. Now, the reason that voltage across R5 is important is because this R5 voltage, I'm just going to erase this right there, this R5 voltage is actually in parallel with another voltage divider, and that is the voltage across the zener and the voltage across R3. Because if you look at this, this side is one side of the equation, and R3, that's the same point as this point right here. So essentially what you have is a series circuit with the 8-volt zener, something like this. This is a horrible drawing, but I'm using an airliner and I'm not a great artist to start with. But we have this 8-volt zener, and then we have a resistor that are in series. So this is R3, and R3 is in series with this zener. So whatever voltage is dropped across the zener and R3 will also be the voltage that's dropped across resistor 5. And resistor 5, that voltage is dictated to by whatever voltage the battery has. And again, we can alter the amount of resistance there from 750 ohms down to 0. So the key here is that what a zener diode essentially does is it will not conduct in this case until it reaches a potential of 8 volts. So any additional voltage that's split between the zener and R3 will get dropped across R3. So for example, if there's a voltage of 10.5 volts, 8 volts gets dropped across the zener, 2.5 volts gets dropped across R3. Now R3 is important because R3 is in parallel with the gate to cathode region of this SCR. And remember, in order to gate an SCR, we have to have enough electrical potential across the gate to cathode. Number one, it has to be a positive potential, and it has to be enough to cause enough current to flow to trigger that SCR. So the key here is anything above 8 volts, even if it's above 8 volts, if it's only 8.1, for example, that 0.1 might not be enough electrical pressure to cause enough current to flow to the gate to trigger that SCR. So keep that in mind when you're doing any mathematical calculations, that you need 8 volts plus an extra voltage that is enough to cause enough current to flow to gate this SCR. So as this battery is charging, and then remember it's receiving current less and less from the supply because it's reaching very close to that peak value, or closer and closer to the peak value. Oh, looks like we had just a little bit of a disturbance there. Anyway, the point being is that this SCR is a switch as well, and we're going to go to the next slide. And what we want to do is we want to just look at this SCR and what happens when we actually exceed the voltage across the 8 volt zener and R3. Now, just a little side note, this capacitor here is there for voltage spikes. It's there to guarantee that whatever voltage is dropped across R5 is a nice steady voltage. So if you get a voltage spike, remember, a capacitor opposes a change in voltage. This means that if there is a large voltage spike, it will actually oppose that so that we get a nice maintained voltage to be dropped across the zener and R3, which of course is in parallel with R5, and it's that voltage that'll trigger the SCR. So the capacitor is really there to make sure that we get a nice triggering voltage for the SCR so that we don't get unreliable triggering when we're not looking for it. So what we're going to do is we're going to go to the next slide, and we're going to take a look then at SCR2 and when the switch closes, or when both switch closes based on circumstance. Well, I guess I don't have it there. I thought I maybe did. But really, SCR2, we know, and really we probably don't need a drawing, although I could go back to this previous slide. So we could look at the switches here in a sense and evaluate what's happening with SCR2. So SCR2, when that battery is reaching full charge, the forward bias switch is closed, because when SCR1 stops conducting over here, when that SCR stops conducting, there's only one other place for current to flow, if it's going to flow at all, and that's through SCR2. But we know then that SCR1 automatically is going to have a positive potential at the anode and a negative on the cathode, which means switch 1 will be closed because it is forward biased. As soon as this 8 volt zener and R3 have enough voltage dropped across that series circuit, for example 8.2 volts, that's going to close this second switch, which is enough to, that 2 volts, which is the excess above 8 volts, is enough to cause enough current to flow to the gate to gate that SCR. SCR1 will then turn on, and what you will see, and again we'll go to the next slide here, what you will see then is if current flows through this SCR here, it's going to actually completely bypass the battery altogether. And really SCR2, that is its role. Its role is simply there to bypass the battery. So once the battery reaches full charge, then what's going to happen is it bypasses the battery so that we don't get gassing. Now, gassing is what happens when a battery continues to charge even though it's at its charging point. And so if we want to eliminate any kind of gassing, what we have to do is we have to increase the resistance right here to a higher value, which will cause voltage to be dropped across the 8-volt zener and R3 sooner in the electrical cycle, which turns on SCR2 sooner, bypassing the battery. If we leave SCR2 off too long, that means SCR1 will conduct and continue to try charging the battery. So that's how you can prevent gassing, is by moving that pot wiper to a higher resistance, which means that again, the voltage across the 8-volt zener and R3 will be reached sooner, triggering SCR sooner, bypassing the battery current sooner. I hope this has helped some. I know there's lots of scribbles and whatnot, but hopefully this will give you an idea as to what's happening in this charging circuit. And just remember, when you actually when we talk about the SCR is in reverse bias, just remember that reverse bias on any SCR simply means that top switch will be closed and the gate trigger is the bottom switch. Both switches must be closed in order for any SCR to conduct. The other thing to remember is that as soon as your holding current drops below its holding value, and we can look at these two SCRs here, and really what happens is that as soon as that SCR becomes reverse bias, that's what drops out your holding current. Remember that whenever there's 3 ways of turning an SCR off, and that is the holding current needs to drop below its required value. So we have frequency commutation, which happens on AC, or we can force commutate, which means we can automatically force the anode to become negative with respect to the cathode. So hopefully that will give you some help. And if you have any questions, you can find me at any time in my office, TR2909. Thanks, and have a great day.